Welcome to Coach Taylor's class notes. Today we're going to be talking about simplifying radicals. So first we need to understand what a radical is. And a radical is simply a square root. And what a square root is it's our square root symbol over x. An example is the square root of 4 equals 2. So square roots are the opposite of squares. And so when we talk about squares, we're talking about numbers like 4 times 4 equals 4 squared. And so our square roots are the opposite operation of squares. And so what that means is if I take the square root of 16, it equals 4 because it's taking away the square. And again, 4 squared equals 16. So it's the opposite operation. And so one of the first things that we need to know is we need to make sure we know what we call our perfect squares. So our perfect squares are 1 squared equals 1, 2 squared equals 2, 3 squared equals 9. Not 2 squared equals 4. Sorry, I said that backwards. 4 squared equals 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And finally, 12 squared is 44. So if we can find these numbers, it makes doing the math of simplifying radicals much, much easier. So let's real quickly look at 2 quick concepts. So if I have the square root of 49 and we plug that into our calculator. Let me get my calculator out real quick. No, come on. And I take the square root of 49. 49 is a perfect square, so that equals 7. But if we look at the square root of 48, it's not a perfect square, so we end up with this big, long decimal. 92820323028. And we don't want to write those decimals. We would rather simplify it without having to do all of those numbers. So now what we're about to work on is we're going to work on how we simplify radicals. So the first thing that I want to do is I want to make sure you have our calculator steps. So most of y'all will be doing this on our yellow calculators that we use every single day in class. And so I'm going to explain those steps to you, and then I'm going to also show you how we can do it in Desmos. And you can pick on the test day which one you like best. So our first step on the yellow calculator is we need to hit our Y equals button. It should be on the top left. Let me write button. Once we hit our Y equals button, we want to take whatever number is inside our radical and we want to divide it by X. The next step is we want to hit our second button, and then we want to hit our graph button. So our second button is the blue button, and our graph button is on the top right-hand corner. And then we want to find our factors with perfect squares. So now let's look at a problem and let's see how we do this. So on the Desmos, I'm going to take the number inside the radicand, which is 96, and I'm going to divide it by X. I'm going to hit my settings button and I'm going to turn it into a table. And on the table, I'm going to type in all of my perfect squares: 4, 9, 16, 25, 36, 49, 64, 81, 100. I usually don't need to go to 121 or 144, but I'm going to put them in there just in case. So on this table, I'm looking for factors of perfect squares. So it's going to be a little bit harder in the calculator because on the yellow calculator, you're going to have to scroll all of the way down and find each of these numbers. In Desmos, we can just simply type in the numbers and see. So I know that 4 times 24 equals 96. I don't care about 9 because 9 has decimals in it. Decimals don't help us. We want to try and get rid of decimals. So I have 16 times 6 equals 96. And then when I get to 49, my numbers are less than 2, and I can't do this if my numbers are less than 2. So that's where I'm going to stop. So now we want to find our biggest perfect square, and we're going to use those numbers. So I'm going to rewrite my square root of 96 as the square root of 16 times the square root of 6, and that is going to equal the square root of 96. So I can break it up that way. So if I remember my list of perfect squares, if I take the square root of 16, I know it's going to equal 4. And so instead of writing the square root of 16, I'm going to write the number 4. The square root of 6 is not on my list, so I'm simply going to write down the square root of 6. And this is how I simplify the square root of 96, is we get 4 square root of 6. All right, so now if I'm using Desmos, I'm just going to simply go on the top of this box on the top of the table, and I'm going to delete the 96, and I'm going to type in 28. So again, we always want to type in the number inside our radicand. So let's look for our factors. And so for my factors, I get 4 times 7. 9 is a decimal, and everything else is less than 2. So 4 times 7 equals 28. So now I need to rewrite my factors as square roots. Square root of 4 times the square root of 7 equals 28. So again, I know that the square root of 4 equals 2. And once I know that, I can replace the square root of 4 with 2, radical of 7, and then that is my simplified answer. So then I'm looking at the square root of 72. So again, I need to take the 72 and write it into my table. So again, if I'm on Desmos, I just simply need to rewrite that right there. So I'm looking for factors that are perfect squares. And again, I happen to have my list already written. Oh no, I typed in 78 and it's supposed to be 72. That's going to make a huge difference. If you're on that yellow calculator, you got to scroll till you hit 4, scroll till you hit 9, scroll till you hit 16, and all of those numbers. So 4 times 18 equals 72. 9 times 8 equals 72. 16 is not an answer. 25 is not going to work. Ooh, 36 is great. And because it's 36 times 2 equals 72, I can stop there. So 36 is my biggest perfect square. So I'm going to go square root of 36 times the square root of 2 equals the square root of 72. And I'm just writing this to remind us that that's how we got there, is that we multiplied those two things. So I know that the square root of 36 is 6. So I'm going to replace the square root of 36 with 6. Since 36 is one of my perfect squares, write the square root of 2, and that is my simplified answer. All right, now we're going to look at 275. Scroll down. 4 is not a factor. 9 is not a factor. 16 is 25 is a factor. So 25 times 11 is the square root of 275. 36, no. 49, no. 64, no. 81, no. 100, no. 121, no. And 144 is less than 2. So no way I can do that. So those are my only two factors. So we're going to go square root of 25 times the square root of 11 equals the square root of 225. So again, we know that 25 is a perfect square. So the square root of 25 equals 5. So I'm going to replace the square root of 25 with 5. 11 is not a perfect square, so that is my answer. All right, occasionally we're going to have coefficients outside of our square root. Our first step is still going to be to find the factors of whatever is inside our square root. So we're looking for factors of 56. So I need to go to my table, and I need to change it to 56 over x. So I get 4 times 14, and that's my only option. So this time, I need to bring my 4 coefficient down. And anytime I'm writing square roots, we have many multiplication signs between them. So 4 times the square root of 4 times the square root of 14, sorry. So I know that the square root of 4 equals 2, not 4. Sorry, guys, it's been a long day. So I'm going to bring my 4 down. I'm going to write my multiplication dot. Instead of writing the square root of 4, I'm going to write 2. And then I know that there is an invisible multiplication dot between the 2 and the square root of 14. You can draw it if you need it, but you do not have to. So now I need to do 4 times 2, which equals 8. And I'm left with the square root of 14. So we get 8 times the square root of 14. All right, so same thing here. I'm going to have this coefficient, and I'm just going to automatically bring it down. And then I'm going to look for factors of 92. So 92, I get 4 times 23. 9's not an option, 16's not an option, 25. And those are my only options. So I'm going to write 2 times the square root of 4 times the square root of 23. Again, I know the square root of 4 is a perfect square, so it becomes 2. So we have 2 times 2 times the square root of 23. I need to do 2 times 2, which gets me 4. And then we have the square root of 23. And that is how we simplify radicals using perfect squares.